Welcome to episode 312 of the Red Dirt Agronomy podcast. I am Dave Deken, and we've got a really cool and interesting episode for you. Today on the Red Dirt Agronomy podcast, we're talking with Oklahoma State University Extension row crop pathologist, Dr. Maíra Duffeck. Before we do that, go ahead and hit the subscribe button where you get your podcasts. And remember, you can find all of the information that we talk about on this episode and past episodes on our website, reddirtagronomy.com. As always, we start with a quick trip around the table for the dream team of dirt and everything that grows from it. Let's start with Oklahoma State University Extension Precision Nutrient Management Specialist.
She's already told you stop asking about aflatoxin.
Dr. Brian Arnall. And across from him is Oklahoma State University Extension Cropping System Specialist.
Us corn producers are planting corn when you're prancing through your wheat fields.
Dr. Josh Lofton. We kind of mix things up in this episode, so be sure and listen all the way to the end to see why an extension plant pathologist is the perfect career for Dr. Duffeck. But before we get to all of that, let's start with a quick crop update with Dr. Josh Lofton. You are listening to the Red Dirt Agronomy Podcast.
Overall, compared to where we could be this summer, we've been hot. I don't think anybody's going to argue with that. We've been hot. It's been a very hot summer. Brian, one of my first summers here, we went all the way through the summer, and I don't think we went above 95 at one point in time. So we've had a lot of various summers since I've been back to Oklahoma. And this summer, we've had sprinkled 100 degrees since May, and it's been warm, and we're very consistently over 100 degrees. So from a summer crop perspective, that could be very bad. But fortunately, we've had a lot of rain, and not everybody's got every rain, and everybody probably didn't want all the rain they got. But we've been lucky enough that we've had these rainfall events sprinkled in. And whole saying in Oklahoma, if you get a rain in July, you're probably going to make a crop.
Yeah.
And we are kind of working towards that. And me and Brian were talking about this morning even, is that compared to where we were 2 weeks ago with the rain that we've gotten recently, it could be a lot different. And things have started to turn around. We started moving in the right direction. The biggest thing that I can say is that one, we're going fast.
Yeah.
We're moving very quickly. We will probably be starting to harvest sorghum.
Yeah.
And so the end of July is a time I don't think we've ever taken a plot out of sorghum in the end of July. Now we got it planted really early, so we got to take advantage of the heat and the warmth early. But it was at black layer last week.
Wow.
So we're moving towards dry down at this point in time. It's mature. Yeah. The crop's done. Yeah. The only thing we have to do is put it in the bin. So we're moving incredibly fast. Things are going really fast. The biggest negative is the bugs. Man, we have a lot of bugs out there. Especially with the folks who are doing double crop. I'm hearing a lot of calls. Got one earlier today of worms coming out and eating early trifoliates, coming in and taking out top growth. And so we're at a point where growers in that case normally in July would just terminate. You know, they'd be going they'd probably be going in and thinking of which wheat variety they're going to be planting. But the conditions are so good for July that a lot of them are thinking of replanting. We're gonna re-put corn in, we're gonna put sorghum in, we're gonna put a forage sorghum in, we're gonna do something because we've got so much moisture, and there's no guarantee in September it's gonna be here still. Yeah. So we're gonna do something. And so I've gotten a lot of calls on replant decisions. I've gotten a lot of calls on pests. Got a lot of calls on, can I still plant? What are my cropping options in the middle of July? And so it's very different. Is very different from the last 2 years, that the decisions we've had to make. But I tell you what, if we were having to make decisions, these are the good ones to make. Is that we have so much good conditions. What do we do if we got empty field? So it'll be interesting when we get to wheat to talk about what that's going to do on those decisions, considering that we were put in the same position early. We were down on our summer crop totals because nobody abandoned their wheat this year because it looked so good. Well, we're now on the same thing, as there's people throwing in really late double crop. How's that going to impact our wheat acres, our grazed wheat acres? What is that going to do? And I think that crop decision makes so much of that. So It's going to be interesting. The next probably 2 months are going to be interesting how this summer lets us out. The good thing is some of our crops that would maybe be a later wheat crop are coming out early. So if folks want to go in and do a grazed wheat, they have the opportunity to, because we're getting a crop out in July and August instead of August and September. But then we have crops that are going in the ground that won't be done until November to December.
Right.
And so what are you going to do with wheat? Amanda's got some great information on some really short season wheat that she might be able to interest you in. But I mean, it really changes the dynamic of that system.
What are you seeing, and this will lead into others, but we've had that interesting summer where we're getting those random rainfalls, and so we're catching some moisture, much needed moisture. We throw humidity, but we're drying quickly. That's a weird thing is we're not staying, the surface soil is not staying wet long. We're doing a rapid dry. Are you seeing in what you're doing a lot of disease pressure going out in the summer crops, corn, soy, and sorghum?
Well, we might have to ask one of our guests on that one.
I know, but I was leading in. I'm asking you, cropping system, what are you seeing?
It's a great question for our first guest, who's our new row crop pathologist. Dr. Duffeck is here with us. So, I haven't seen a ton of diseases, but you work a lot in crops that are known to get diseases in the state. Mainly, we're talking about cotton, peanuts, and all that. So what are you seeing as far as disease pressure in the state?
All right. Thank you for the question. And it's a pleasure to be here talk with you guys today. We start to have a very interesting beginning of the season. Our soils were very humid and we received a lot of rain for the beginning of the season. But after that, as was already mentioned, we dry out. We haven't been receiving some rains, but it dries so quickly because our temperatures are so high that are not favoring the development of those diseases. We used to say as plant pathologists that when the conditions are favorable for the development of the crops, is also favorable for the development of diseases. So when the summer crops are suffering with the heat stress and the lack of rain, the pathogens are suffering the same way. I received some calls in the beginning of the season regarding seedling problems, especially for sorghum and soybean. Not too much for corn, though. I'm not sure if I just didn't catch that or the conditions were not there. But for sorghum and soybean, definitely we had some problems of pathogens affecting the stand of those crops. Mostly caused by pathogens that like that more cool soils and with abundance in humidity and wetness. So we see some soybean especially being infected by Fusarium and also by microfomina. That's supposed to be a pathogen that affects the plant in the end of the season when the conditions are dry, but it also infects the plants in the beginning of the season if the soils are cool and wet enough to favor the development of that seedling disease. For sorghum, the same scenario. We have seen some sorghum seedlings being affected by Fusarium, and we know that Fusarium is a pathogen that it is everywhere, but it's just going to infect it when we have the right conditions for that pathogen. And for the growers that didn't have a seed treatment this year, in the beginning of the season was very tricky for them because they really feel the difference among the plots and the fields where they had that seed treatment in and where they didn't have it. It really affected the difference in the stands that we saw. Regarding the other disease in the ongoing of the season, not so much to talk about it. As we already mentioned, we have been very dry and is not favoring the development of foliar disease. I just counted some sorghum and some corn fields this morning, and the fields are clean. Corn fields are looking very good. The ones that are planted in May, in end of April and May, they look very good because they catch the rains that they need to catch in the right moment. But it in the same way, the warm conditions and the heat that we have been experiencing in the state didn't favor any foliar disease. For soybean, though, we plant a little bit later than corn, so we still need to monitor for it and see what the condition is going to tell us. Right now, I would not recommend a fungicide application for any of those crops. But as Josh said, I cannot predict the future, so we need to keep our eyes open in what the condition is going to tell us. We know that in Oklahoma, we plant varieties that are susceptible. We have the inoculum here, but we need that right environmental conditions for having the development of those diseases.
I was talking to a grower this morning, and I think it's one of those things that sometimes our conditions in Oklahoma, we learn a lot from a year, but then we don't see that type of year again for 3 or 4 years, maybe a decade. But we were talking about, they felt like they saw a lot of early season insect pressure and had some issues with seedlings dying out. And, in the time that they planted, they were incredibly wet. So we had to re-talk about, seed treatments being washed out of the system and being, you get a 4-inch rain after you put seed in the ground and the seedlings up, then I don't know how much of your seed treatment you still have in that active zone. So yeah, you put seed treatment out. It should be protecting against the insects and the diseases, but you also got 4 inches of rain. It's not there anymore. Same thing works with fertilizers.
Well, I mean, I'm going to say how often. So, I basically lost seedling blight in the Panhandle. Am I going to bank that the Panhandle receives more rain in a 1 month period than it does over 2 years every season? I don't think so. They would probably like it, but this year I went on my normal planting date out there in the high plains. It's done exceptionally well for the last 4 years on cotton. I plant early. I plant a long variety, and I get it out. And this year I planted, it stayed cold. We kept getting rains. Seedling blight in cotton, which is my understanding, all the things. It could be called seedling blight. It's a generic term that anything happens. And massive stand loss with residue coming over row with just seedling. I mean, we had plants that were showing 3 or 4 nodes that are no taller than 3 or 4 inches with just one leaf left.
I think that's the critical, how cold it was early. And so while we had these warm days, the soil temperatures, especially no-till, were generally cold because they were so wet. And it's one of those things in a normal year, same conditions, but it's warmer. We probably grow out of those seedling conditions faster than the disease can kind of lay itself in. But in these cold conditions, they're in that susceptible stage for so long that it's almost inevitable. Like you said, the pathogens here, if you stay in a seedling position for a month, those conditions are going to come.
No, I completely agree with that. If you plant and the seeds stay in the ground and the seedling doesn't emerge from the ground, at some point the fungicide is not going to be efficacious anymore, and it's not going to protect against plant pathogens, neither insects. And that's the problem that we saw in the beginning of the season. We had this very slow movement of that plants getting emerged from the soil. And they are not strong enough to fight against that disease, that pathogens that are in the soil, because the seed treatment is just to help out the plant to get it started, right? But when you have that very slow development of the plants, the seed treatment at some point is not going to be provide the same efficacy as a normal year where that plants emerge faster from the soil.
And I want to say across the board, because now I get to deal with the SWAFL and soil testing labs, so I get a lot of those calls. Even a lot of the local gardens have been talking about just the slow progression of plants, whether it be bell peppers or this statewide. We've got this slow. So my question to you, Maíra, is that if we look at this, let's just say I'm planting soybean, and I expect to plant, and I get that rapid emergence, rapid growth. Is there a point to say, okay, my soybean's not growing at the rate I would expect, so I should probably put a preventative out? Is that, maybe you're behind growth stage the first week or two, or at what point, how big does the plant get to get past some of those seedling issues?
That's a good question. Most of our pathogens, like the ones that cause SDS or causing charcoal rot in soybeans, they infect the plant when the plant is very young, but we don't see the symptoms until the reproductive stages. So it's very difficult for us to say exactly when is the point that, okay, we're safe now and we are not going to suffer any problems with seedling disease, because we call seedling disease the disease that we can detect it early in the season, right?
Yeah.
But we have other disease that actually affect the plant in the reproductive states later on in the season that was infected as a seedling, but the symptoms we're just going to see in the end of the season. So it's very difficult for me to answer this question correctly for you and say, okay, that's the point that the growers would be safe. I my impression is that some pathogens that cause SDS or charcoal rot, they're still going to infect that plant a little bit more late. But how late is that? I don't have this answer for you right now.
Random dumb question. Is charcoal rot in sorghum the same pathogen as soybean?
It is. We have been arguing that the pathogen that causes charcoal rot, that's Microphomina phaseolina, is cosmopolitan.
Say that 10 times fast.
Sorry.
No, you're good.
All right, it's just the pathogen is a fungi that causes charcoal rot.
No.
I learned it, and I learned the name in Portuguese, so I'm kind of translating for English, so it's even more hard. But it is a pathogen that's supposed to infect more than 500 plants. So infects corn, infects sorghum, infects soybean. So it's very difficult to manage because the options that we have for rotation are very limited. What I'm seeing that some researchers have been doing recently is try to understand better the biology of this pathogen to see if really is the same pathogen that is infecting all these plants, or if we have some difference in the biology of this pathogen that help us to understand better the disease cycle of this pathogen in all these different crops. Because if you think about it, even strawberry in California is a crop now that's suffering a lot with charcoal rot. So it is a very broad spectrum pathogen. Is very difficult to manage for sure.
So I guess the question is, well, besides that, it might just be another casual pathogen but why, even in years like last year, to where we saw a lot of charcoal rot in soybean, we saw a tremendous amount in sorghum, it seemed like corn was ill affected. And I can't, maybe Brian, you have, I don't think I've ever seen a year to where growers are like, I mean, we just got to pull in the tanks. Charcoal rot's too bad in corn. And I might not have heard that, but are there other like environmental conditions associated with corn that make it to where even in a year that it could be really bad in sorghum and soybean, it just isn't in corn?
Mm-hmm. What we know is that for some crops as corn, actually, I state that a little bit. I need to state this a little bit different. The pathogen is there and it is infecting the plant, but the symptoms are not obvious in the same way that is for soybean. So we say that they multiply. Actually, is a better word to say that. The pathogen that causes charcoal rot multiplies in corn and also in sorghum, causes disease in sorghum, but the symptoms, we don't see the evidence of these symptoms in the same way that we see for soybean. Soybean is definitely a crop that's more affected by charcoal rot. It's more susceptible. For some crops, we see the pathogen multiplying, so is it surviving in the next crop? Is multiplying, the inoculus increasing, but the symptoms of the disease is not sometimes there.
So I'll be honest. I usually associate charcoal rot with sorghum and know the problems with it. I didn't know until today that it was in soybean. So what is the are we talking about lodging? Is it just plant death in soybean? What's the impact of charcoal rot on soybean?
In soybean, it ended up wilting the plant and killing it over time. So we start to see this early senescence of the plants in the field, and then we don't have the conditions for doing the pod filling, and it definitely is going to decrease our yields. The thing that's difficult to diagnose charcoal rot in the field is that most of the time charcoal rot is misdiagnosed and mistaken with other problems that we have in the field, such as areas where we have compaction, areas that the plants are already suffering with drought and heat stress, is the same conditions that favor the development of the disease. So it's very common for us to go in a grower's field and the grower says to us, this is a part of the field that is being more dry throughout the season. And we go there, we pull up some plants, and then we see the formation of these black structures in the stem. You can open up, or sometimes even outside the stem of the soybean plants that the pathogen produce microsclerotia. That is a very small, very tiny black structure that's going to survive from one season to another. So what we really see in the field is the presence of this, I would say this gray color is a different color when the plant is senescing in the right conditions, when the plant is healthy, that we see like more a yellowish, brown. But for charcoal rot, it's kind of a grayish color that you see in the field. You can pull up some plants. You say that the pod didn't finish the filling process. The yield got reduced. And when it's a little bit early in the reproductive stages, we can see that the plant is wilting. So in hot days especially, you can say that that plant is suffering more than others that doesn't have the disease.
Yeah, I mean, and you can even see it with, like, once you open that stem, that vascular tissue's just dried out like styrofoam. And so, like, it's drought conditions just on steroids. You know, it's the quicker formation, and that's how I've always seen it in Oklahoma. Is just things look droughty. It's just been season long. It's always been off, and that's kind of what they kind of diagnose there. So I guess one of the other big things, and we can clip it out if you want to, but we definitely won't, is we always have an issue with aflatoxin. I mean, do we think this is an aflatoxin type year, or have we surpassed those conditions that we're probably in the clear of aflatoxin? Have you gone and seen some that have that aflavus in the field that we might be looking for that?
I scouted some fields, but I haven't seen any ear rot problems. I saw some caused by Fusarium, though. That's explained because some fields have been receiving more rain. And when that plant was infected around R1, R2, the pathogen sometimes is there, multiplying, but it's not causing the symptoms. So now in the end of the season, before harvest, we're able to open up that ears and see if you have any damage caused by fungi. I haven't seen anyone with aflatoxin, the Aspergillus flavus that cause aflatoxins, but it's something that we need to look for, especially in areas that didn't receive as much rain as in the west side of the state, because we have been dry in these conditions. This stress, this heat stress, this lack of humidity favors the development of the disease. So I would say we need to scout for it. I personally haven't seen this season yet.
Here's a question for either one of you. If we're looking at chopping and silage corn, does that get tested for aflatoxin? Does it matter? Because a lot of that goes into the dairy system. So
I think that's, but I think most of the time that gets chopped pre-establishment of a good aflavus. So
is there a good and a bad?
Well, so aflavus isn't an issue. The aspergillus is not an issue because not all aspergillus produces aflatoxin. So I'll let our pathologist go on with that one. But
please tell me wrong. I like it when you correct him.
No, I'm not correcting him. He is correct. That's a very interesting statement. I don't have a lot of... I never worked directly with this pathosystem, but I know other researchers that work with that. And it's very interesting because we do have some pathogens that they don't have the genes or the QTL that's part of their genome that produce the mycotoxins. Because most mycotoxin production is very complex, and it's very difficult to manage these pathogens because of that. Because it's not just find that single gene in a plant that's going to kind of manage that mycotoxin, because there's so many genes involved in the production that is very hard to for the geneticists work with that. But there is some aspergillus that do not produce the mycotoxin, and this is actually one of the management strategies in some states where the presence, especially for peanuts, that's also affected by aflatoxins in Georgia and other states, they can sometimes inoculate this pathogen that doesn't produce the mycotoxin in the field for this pathogen to kind of steal the infection site from the fungi that is in there but produce the mycotoxin. So it's a kind of a competition. They inoculate the pathogen, but the pathogen is not going to cause any problems for neither the plant, neither the humans, but the pathogen is there and is stealing that infection site from other fungi that produces the mycotoxin.
Well, and going back to your question, the other interesting thing, which I don't know the answer to,
I never hear him talk about it. So
is during the ensiling process, if the mycotoxin is degraded during ensiling, and I don't know the answer to that. That's a good question. I really don't know. But you're right. I've never heard of it. So I would imagine that at some stage in that game, either it's chopped too early or during the ensiling process, you get.
For this question, the research that has been done for corn, at least, is more with not with the pathogen that produce aflatoxin, but with Fusarium graminearum that actually produces deoxynivalenol in the plants, because this is the one that infected around R1. Maximum R2 growth stage. And then if we have a year where the environmental conditions favor the development of this pathogen, the concentration of this mycotoxin can be a little bit high in the moment that we are already doing this process, especially for milk cows, the insulation of that crop. So a lot of people are, especially in the north part of the United States, they are looking into that. They are collecting samples and trying to understand what are the conditions that favor the development, not just the development, but during the process of ensiling that corn, what are the factors that increase the concentration of that mycotoxin that can be dangerous for livestock, for cows, especially dairy cows. But most of the time is what Josh also mentioned, that we kind of escape a little bit of that that phase where the concentration of that mycotoxin in the grass is so high that's gonna to affect it, the animals.
Well, because
it's also diluted.
Because I mean, correct me if I'm wrong. Please do. Brian's waiting for it.
I'll pay you money.
But there's a time in which Aspergillus forms. Kind of establishes itself. And that needs a certain set of environmental conditions. And there's a time that once the Aspergillus is formed, that it creates that aflatoxin. And I think that is much later in the process. Is it?
You're asking me about aflatoxin. That is a field that I do not dominate. I just want to mention this is this podcast. I can talk more about Fusarium graminearum that produces deoxynivalenol in the plants, because actually I work a little bit with. A little bit, no, I need to say almost my whole career with that.
Well, because it was an interesting thing, because we normally have that nice, wet, humid, flowering anthesis process, and then we dry off on the back end of that on normal planted corn, Brian. Whenever you're doing your little prancy thing through the wheat fields, we're normally planting corn. Us corn producers are planting corn when you're prancing through your wheat fields.
Our next infield video will be me prancing.
But now you've even got me on a weird spot. So you can have these conditions, and then as it dries out, as the grain starts to form, I mean that's where we always got into some really bad issues. Is that what the interesting thing is?
Maíra wants to talk. Let her talk. I don't like you anymore.
Half hour ago I couldn't talk yet, but that's fine, Josh. Go for it.
Well, the interesting thing is, a couple of years ago, remember when we had the other mycotoxin?
Yeah.
It was out in the Panhandle, fumonisin. What did you do to your hand?
Oh my!
Explode.
Oh no!
See, that's what you get for writing notes. That's what you get for writing notes.
Exploding
There's your pen.
But that was a whole nother set of environmental conditions in itself.
Fumoxitoxin, is that what it was?
Fumonisin.
Yeah.
And by the way, I do want to say we'll have a complete glossary of all of these big scientific words available at reddirtagronomy.com. So be sure and download the
Dave, can you please put a word search together for?
I am. Whew, okay, back to the show.
She had a hand raise earlier.
Oh, I'm sorry.
Yeah, something that I really wanted to mention here is that sometimes we don't see the development of the fungi in the grains, but the mycotoxin is there. Because mycotoxins are considered a pathogenesis factor. The fungi use the mycotoxin also to invade the tissue of the plants to help with colonization. So it's very important that even in years that we don't see the development of the fungi in the corn ears, we still recommend the growers to test for mycotoxins because, as I mentioned, sometimes we are seeing zero development of the fungi, but the mycotoxin is there because the fungi produce that as a a way to colonize the tissues before that fungi spread in the tissues.
The interesting thing is, in really unique years, we have the chance, especially in eastern Oklahoma, to develop frog eye. Mm-hmm. Have you heard any reports of any frog eye showing up even on the east side of the state, or are we pretty clean on that?
I didn't receive any report yet of foliar disease in soybean.
Okay.
I have some fields in the eastern part of the state, but so far they look pretty clean. But everything is going to depend of the next steps, what weather is going to do. Last year, for example, we are also very dry and very hot during the reproductive stage when they start to see the development of more late season foliar diseases. And I didn't see a lot. I just saw some cercospora leaf blight in the end of the season, especially for double crop, the fields that are planted a little bit late, because we did got some rains last year in August, middle of August, that favored the development of that cercospora leaf blight. But besides that, I can talk regarding last year, this year, pressure of foliar disease has not been high. And I'm not even recommend a fungicide application right now if your plants are in the right reproductive states.
Well, I mean, I'm thinking even out of the Midwest group, I haven't seen a lot of reports, minus like the northern states that have been so wet and through that region. I'm trying to remember. I'm not seeing a ton of reports. We're early.
We're still early. You know, we're just now starting to put on flowers and early pods. So I mean, we're really early in this process. I don't think I've ever seen foliar disease. Well, I mean, I probably have this early, but I mean, we're really early for this, and we won't get that true humidity kind of setting in until August, which is when I think we usually get a lot of our diseases start popping
One of
up.
the problems is not just the humidity, but the temperature, right? We have reached, even during the night, high temperatures, and this can help to break the cycle of some diseases. Pathogens like high temperatures, but they also, some of them you can end up breaking the cycle when the temperatures are too hot.
I did not know that. That's intriguing. So is there some thresholds that you would look for? Is, what is high? Well, let me ask you this. Is it more about the daytime high or the nighttime low?
We have been seeing that the increasing of temperatures during the night are somehow influencing the cycle of these pathogens. And also of course, that when you reduce the relative humidity in the air, when you don't have the accumulation of dew in the plants in the morning, this can also influence for the lower disease development. But we see that the temperatures during the night influence a lot the development of some diseases in general.
What's some of the ongoing work, whether it's here or elsewhere in SDS? Because that really hit mainstream media a while back, and it kind of, to me, it seems to flux. Like there's a lot of chatter about it, then it goes quiet for a little bit. So what's the ongoing work with SDS, and can you maybe explain what SDS is?
SDS stands for sudden death syndrome. That's the reason we use SDS to make it shorter to say over time. It's caused by a Fusarium a species, actually, that calls Fusarium virguliforme. Fusarium is everywhere and causes a lot of disease. It is in the soil and infects the plant, as I already mentioned, very early on in the season. And the conditions that favor the development of this disease is the same that favors the development of other seedling disease in soybean, that we do have more cooler and wet, cooler temperatures of the soil and more wet conditions in the beginning of the season. However, this pathogen, we're going to start to see the symptoms of this pathogen in the soybean plants during their reproductive stages. What happens is that the pathogen stays in the root system and the stem of the soybean plants. And what moves in the plants is the mycotoxin that's caused by this species of Fusarium as well as other Fusariums that produce mycotoxin. So when you see that the symptoms that we have that yellowish among the leaf veins that remain green, especially when the plant is already in R2, R3, towards the end of the season, is a symptom of the SDS. And in this point, if the growers decide to send some samples for analysis, they cannot just collect the leaves. The leaves for us is not, we can see the symptoms, we can say that it's supposed to be SDS, but we need to have the root system and the stem of that soybean plant as well, because it's from the stem and the roots that we are able to isolate the pathogen and really provide a right answer regarding what is the agent that is causing that symptoms. Because as I mentioned, the pathogens stay in the root system and the stem. What moves that is translocated in the xylem of the plant is the mycotoxin that's produced by that pathogen.
Even from like 10 years ago, the management for SDS has changed a lot on seed treatments and genetics and stuff like that. That it's because whenever I was in Louisiana, we found it was basically you just aren't a soybean farmer anymore. You need to go to corn. You need to go to cotton. It's, because you till it, you spread it. Even we found that irrigation water moved it down the field because
surface flow.
Yeah, just that surface moving that soil down the field, and so that's just not the case anymore. I don't know how effective some of these management strategies are, but there's a lot of dollars in soybean going into SDS because it is such a widespread issue in the soybean growing region.
We do have, I will not say that the management strategies, they change over time. I think we learn how to select them better and we know what's working, what's not working for SDS. So the first one measure that we use to manage soil-borne disease is everybody know that's crop rotation. So for SDS is not different. Crop rotation with other crops such as corn, plants that doesn't host this pathogen is still the first one. I think we did a better job to select some seed treatments that are more effective to manage SDS than other seed treatments. We do have a material in the Crop Network Protection website that is updated every year, and this include a table of the efficacy of seed treatments for managing seedling diseases. I do recommend, if you have questions about that, to consult that material. We can link probably this to the episode. I have a researcher in Kansas State University that is working a lot with SDS. He's inoculating the fields every season, and he is doing the selection of some seed treatments that work better for SDS. But not just that, he's also looking at the influence of fertilizers. And how the fertilization that we're using in the beginning of the season is also impacting the development of the disease, to reduce or to increase the development of that disease in the beginning of the season. And he doesn't publish yet all the complete results, but I know that he's looking at that, and we're going to probably see some of those published in the next years, especially regarding phosphorus and potassium and nitrogen, the micronutrients, and how this is impacting the development of the disease.
But before we wrap this up, I do want to ask, you're from Brazil. Why
was it the accent, Dave, that got
well,
you?
it was either that or Jersey, and I couldn't really. But tell us about life back in Brazil, and then making your way to the U.S. and then on to Oklahoma. This is probably something we should have started with, but Josh,
I was wondering if you guys gonna ask me that. But
Josh did such a fantastic job transitioning into your expertise. But let's talk about what life was like back in Brazil and your way to Oklahoma.
All right, sounds good. Yeah, I grew up in a very small farm in the south part of Brazil, in a city that is so small that neither the Brazilians know that I exist. It calls Monte Castelo, has 8,000 people, so it's a small city. And I grew up among farmers. My father was a farm, my family still farms, and I was always surrounded by extensionists.
Really?
So extension also play a huge role in my life because we had this state specialists, I would say, that used to go to my father's house, to go to my aunt's house, and provide guidelines regarding what was the best to do in that moment. And I grew up with that environment of being assisted by someone from outside our farm. And growing up, my dream was to become an agronomist because I also had the same dream of doing the same.
Yeah.
Of sharing knowledge with people that has less knowledge than I would have if I decide to go for a degree. In 2010, I started my bachelor's degree in agronomy then, as was my dream. I finished in 2014. And during my time as an agronomist, I was lucky enough to conduct research. So I was working with onion production in a region that is the main onion production in Brazil, that is in Santa Catarina, or the state that I grew up. And there we face a lot of problems with disease, especially leaf diseases. And was the first time that I started to do some plots and test some difference in fungicide applications, collect some disease data, try to understand the cycle of the disease and what are the factors that are affecting the development of that in the field. And I was lucky. I published some papers out of that, and we helped the EPAGRE, that's the extension agents for the state, to develop 2 models that now are in use by the growers.
Oh, wow.
Where they can monitor the risk for the infection and then help them to take decisions regarding fungicide applications. And they're able to decrease the number of sprays that they use for that crop right now, because it's a high intensive management for onion production there. So if you reduce 1-2 applications is already very good and enough to help the growers make more money in the end of the season. Because of that, the experience that I gained throughout my undergrad, then I decided to do a master's in plant pathology. I was selected in Federal University of Viçosa. It's not in São Paulo. Most of people from Brazil are from São Paulo, but I had my degree from Minas Gerais state, that is in the central part of Brazil also. And I worked with Fusarium head blight in wheat. So all my career actually was focused on wheat, and now is the only crop that I don't work with. What's kind of sad. I had more experience with wheat and corn than other crops, but not working with wheat here at Oklahoma State University. But then I started my master's there in Federal University of Viçosa, but I actually didn't finish. I jumped for the PhD.
Yeah.
And then started my PhD. My professor told me that it would be a great experience for me to come here to the United States and learn a little bit about the agricultural production here. And I did that. So in 2018, I arrived at Pennsylvania State University, where I stayed for 2 years. Also work with Fusarium head blight in wheat because little research have been done to understand that pathosystem in there.
Right.
So I focused on that and finished my PhD under COVID. It was a challenge, was not easy. I need to let some field and greenhouse experiments behind because we are not allowed to do any research that year. But it was good because I could defend my PhD by Zoom. I didn't need to come back to Brazil. And if I had come back, probably not be here now because the embassy was closed. So I'm going to I need to renew my visa at that point, so I'll not be allowed to come back. And because of that, I was able to get a postdoc position at Ohio State University, also working with wheat and corn, especially focus on ear rot in corn and Fusarium head blight in wheat. And I worked there during 2 years of my career. It was a great experience. My advisor there is extensionist, such a way as I am now at Oklahoma State University. So he taught me a lot about extension and what are the tools that we need to make extension happen. And on my second year, I saw this position open here, and I know that was not for wheat, to work with wheat, but then was to work with other crops that was challenge for me actually, because most of the crops that I'm working right now in the state are crops that I haven't been worked throughout my career.
Right. That's
cotton, peanuts, sorghum, soybean. I already have a little bit of experience, corn too, but other crops I'm start kind of from zero and learning a lot. And in 2023, in January, I started this position here at Oklahoma State University as the row crops extension pathologist. And yeah, since there, learning a lot and glad to have the support of several crop agronomists that can give me a help me to produce the crop and make them survive throughout the weather that we experience here in Oklahoma.
And forced her into uncomfortable podcast.
That's true.
Well, thank you so much for coming in and putting up with these guys throughout the podcast. We really appreciate having you on.
Oh no, thank you for inviting me. I'm really glad to be here, and I expect for the next podcast maybe we face more disease problems they state, and I can have more answers for you guys. And I'm gonna search about aflatoxin, Josh. Don't worry about that.
Thank you for listening in on this conversation of the Red Dirt Agronomy Podcast. And if you'd like to join the next discussion, send us an email, podcast@reddirtagronomy.com, or send us a tweet. Of course, our handle is Red Dirt Ag. We'd like to thank Dr. Maíra Duffeck for joining us on the podcast and, more importantly, putting up with Josh and Brian. And of course, if you get a chance, visit our website, reddirtagronomy.com, to find out more information about our guests and any of the resources that we discussed on the podcast. For Dr. Josh Lofton and Dr. Brian Arnall, I'm Dave Deken, and we all want to thank you for listening. The preceding is a copyrighted recording of Ag Now Media, LLC, 2024. And yes, all rights are reserved.